This is question 5. We're told figure 2 shows a plan view of the garden. The plan of the garden ABCDEA consists of a triangle ABE joined to a sector BCDE of a circle with radius 12 metres and centre B. The points A, B and C lie on a straight line with AB equal to 23 metres and BC equal to 12 metres. Given the size of the angle ABE is exactly 0.64 radians, find A, the area of the garden, giving your answer in metres squared to one decimal place. The question carries 4 marks. So what we're looking at then is the area of a triangle and the area of a sector. What I'm going to do is just draw this up, and we're going to first start with the area of the triangle. If we look at the area of the triangle, we have the angle, and that's 0.64 radians. So if we just write this in, 0.64. We've got the enclosed angle here, we've got 23 and we've got 12. We can use now the area is equal to 1/2 AB sine C. So using the information, we can say now that this area, which I will call area 1 will be equal to 1/2 multiplied now by the 23 multiplied by the 12 multiplied by the sine of the 0.64. We need to ensure that the calculator is in radians mode. So if I do this now, putting my calculator in radians mode, we've got shift mode 4. We're going to have 0.5 times by 23 times by 12 times by the sine of 0.64 radians. So if we go ahead and do that, we can see now that that's 82.41 and so on and so forth. So 82, let's write this down, 82.41 ... and so on and so forth. Let's just go ahead and tidy that up. I'm going to store this value in my calculator as A. So what we'll have is 82.41 and so on and so forth, and that now will be stored in. So shift store A. If we now consider the area of the sector, I need this angle here. Angles on a straight line will add to give pi radians, or if you like, 180 degrees. So what I'm going to have is this angle right here, and this will now be pi minus 0.64 radians. I'm going to use this exact value here and plug this straight into a calculator. So what we've got then is the area of the sector, and if we just sketch that out, we've got the information that we require. We have now the radius, which is going to be 12, and also the angle. So if I just draw a quick sketch, it looks something like so. So this angle right here is going to be pi minus the 0.64. We have 12 and we have 12. We can say that the area is 1/2 r squared theta, where theta is the angle measured in radians. So if I call this one area number 2, we can say that area number 2 will be 1/2 of 12 squared, which is 144, multiplied now by pi minus the 0.64. So let's go ahead and do that. So this will give us area number 2. So we'll have now 0.5 times by 12 squared, or 144, times by now pi, and shift pi in the calculator, minus the 0.64. That's going to give me now 180.11 and so on and so forth. So let's go ahead and write that out. We can say that area 2 is going to be 180, and then we've got 0.11 ... and so on and so forth. So all I'm going to do is simply now add the two areas. So area 1 plus area 2, we're going to have now 180 plus the 82. So I'm simply going to add to this now the value of A, which is stored in the calculator. That's 262, so let's write this in, 262.5, and then just jotting down the decimals, 276 and so on and so forth, and we're giving this to one decimal place, therefore we can say that it's going to be 262.5. This will be meters squared, and that is correct to 1 dp. So just writing this in 1 decimal place. In part B, we need to find the perimeter of a garden, giving our answers in meters, or giving our answer in meters to 1 decimal place. So what we need then are the lengths. We already have the 23, we already have the 12. We need AE and also we need EC. So we need an arc length and also a missing side of a triangle. If we take our triangle here, we can use the cosine rule. We have an enclosed angle. So if I just sketch this up, what we have here now is our enclosed angle. These sketches don't have to be immaculate, they just give us some idea now of what's going on. So this is going to be the 0.64. So we have the 0.64, we have 23 and we have 12. If you want to label this up, this is going to be angle A, this will be side A, this will be side B, and this will be side C. We can say using the cosine rule to find the length of A squared is equal to B squared plus C squared minus 2BC cos A. So all I'm going to do is simply find now the length, and that is AE. So let's go ahead and do that. So we can say now that AE will be equal to the square root of B squared, which is going to be 23 squared. Then we're going to have plus C squared, which is 12 squared, minus 2 lots of B, which is 23, multiplied by C, which is 12, multiplied by the cosine now of 0.64 radians. So straight for the calculator with this one now, I'm going to plug that in. So we're going to have now the square root of 23 squared, then we're going to have the 12 squared, then we're going to minus from that 2 times by the 23 times by the 12 times by the cosine of the angle, which is 0.64 radians. So I'm just going to go ahead and work this out, and we end up now with 15.17 and so on and so forth. So AE is going to be now 15.17 ... and I'm going to store that as A. So what we can do is just write this on. So this is for 15.1 and it's 17. Let's have a look at that 17, and that's going to be on there. So we now have this length AE. All we need to do is find the arc length and then add it to the 15.17, the 23 and the 12. So this is going to get stored in the calculator. Shift store A. What we now need is the arc length. We can use now r theta. This length right here in general is given as r theta. So what we can state then is the length, or the arc length, is r theta. So from this, taking now EC, we can say that EC will be equal to the radius, which is going to be 12, multiplied by theta, which is going to be now the pi minus the 0.64. So all I'm doing here is simply looking now at the arc length. Here is our arc. We want that arc length. We've got E just here. We've got C just here. We have a radius of 12, and we have this angle here of pi minus 0.64. This length right here, L or EC, is just r theta. It's 12 times the quantity now, pi minus 0.64. So if we do that, what we're going to have then is 12, and then we'll have now pi minus the 0.64, again, answer in radians, and that's going to give us 30.019 and so on and so forth. So we can say now that this EC is going to be equal to 30 point, and it's 30.019 ... I'm going to call that B. So if we just store this in, shift store B. So what we have then is the perimeter, and just writing it here, is going to be now AE plus EC plus now the two values that we've got. We've got the value here of 12 and 23. So let's go ahead and do that. So plus the 12 plus the 23. So if we look in the calculator, all we need to do now is A plus B and then plus the 12 and the 23, which is going to give me 35. That gives me 80.19, so we can write that this is 80.19 ... and so on and so forth. We need to give this to one decimal place, so we can say it's 80.2 meters, and that is to one decimal place. So a few different ways around that. All we're doing is simply now summing two different areas and then finding a missing length on a triangle and the missing arc length and adding them together.